Now I would like to consider the question of whether a mass moving in a straight line can have angular momentum. We're used to objects spinning or masses rotating about some axis of rotation having angular momentum, but a mass moving in a straight line doesn't have any sort of rotation or curved trajectory, so it seems like it can't possibly have angular momentum. But let's think of this thought experiment. From my point of view, a mass moving in a straight line is traversing some angle over time. And so I could theoretically calculate the angular velocity of this mass. So perhaps I can also calculate its angular momentum from my point of view. And this is where the definition of angular momentum being equal to the cross product of r cross p really comes into play. So if we have some mass with linear momentum p, then the angular momentum about some point q, which is perhaps where I'm standing, can be calculated by the cross product of this displacement vector r and the linear momentum p. Now if we recall that the magnitude of a cross product can also be written as rp sine theta, where theta is the angle between the displacement vector and the linear momentum vector, then we can see that the angular momentum just depends on the r sine theta component of the displacement vector. And that's just this perpendicular component here. So that means that if this mass is moving in a straight line, we're always going to calculate the same angular momentum relative to point q. Because all we really care about from this displacement vector is this perpendicular component, which is not changing over time. But however, if I measure the angular momentum about another point, for example, a point here, we might get another value for angular momentum. Anyone want to guess what you would get for the angular momentum about this point?
0.
Yes, it's 0, because the r sine theta component is now 0 from this point. So obviously it really matters what point you choose to calculate the angular momentum about. And that usually depends on the problem you want to solve. If this mass is moving forward and then suddenly hits a dumbbell that will start rotating about its center of mass, then the angular momentum we want to calculate for this particle is relative to the same axis of rotation. So we'll explore this further in the next problem.